So my interval of convergence is the open interval from -5 to +1. So y'all tell me, what do you think? Let's say that I gave you this problem on a test, right? Let's say I gave you this problem on a test. And you work it out, okay? You work it out. You run your ratio test. And then when you run your ratio test, you get your radius of convergence, right? And then you had that, when you did the radius of convergence, you get to that point where you have this written. Okay? This is the last line that you have written. Okay, that's the last line. You run the ratio test, you tell me what R is, and then you write this down, and then from that, you give me this answer for interval of convergence. But you don't check the endpoints. Is your answer correct? Yes. How much should I take off? So if the problem's worth 10 points, and all you did was ratio test, and you never checked your endpoints, your answer is correct, right? This is correct, but you never checked your endpoints. How much do you think that that's worth taking off? -5? 5? Well, you have to check both endpoints, right? Yeah, so 5, do you think 5 is excessive? I don't know. Yeah. No, I'm saying it's worth 10 points. I'm saying if the problem's worth 10 points, you think if you don't check the endpoints, it's like half. I kind of look at it the same way. I look at it the same way. Because if you don't check the endpoints and you get the right answer, you got lucky. You got lucky, that's all. Because it could be both endpoints. It could be. And not only that, you're not even demonstrating that you know how to run tests, right? Like, okay, end-term test, alternating series test, comparison test, right? Like all those things you're just kind of skipping over. So I'm telling you, be prepared for this, right? And do your homework. We're done. We're going to come back next week. We're going to move into the next section, which is representing functions as power series. So that's where we first start to make connections between a function and how to turn it into its power series. And hopefully we'll get into the next section. We have to get into the last section. We have to. Maclaurin and Taylor series. Yes? This was 8.5, yes. This is all 8.5. Do your homework, okay? Do your homework. Don't just sit there and say, oh, I have last semester's final, so I should be good if I can do this. I'm not doing any homework.
I have a question.
Yes?
When you ran the limit on that one, when you put infinity, that one, infinity over 3 would be infinity.
Yep.
It just could be infinity, so it's not 0, right?
Well, that goes to infinity, right? This right here just changes the sign. So if you just look at this as a sequence, just look at a sequence. If I plug in 1, what would happen? 1/3, right?
Yeah.
And then -1 to the 1 would be negative, right? So it'd be -1/3. So if I plug in 1, I'm down here at -1/3.
Yeah.
And then when I plug in 2, what happens? 2/3, right? But now positive. So now it's at 2, I'm up here at positive 2/3. The next one will be negative, but it's even bigger, right? And then positive, bigger, negative, positive, negative, right? And it's like, is that going to 0? No. The end-term test says it must then diverge. Okay?
And when you ran the one on the other one, it's just gonna be
This one, yeah, it's just like, this one is not, this is the exact same thing, but it's not alternating. So it's just like 1/3, 2/3, it just keeps going like that. Yeah? Okay, good. All right, I'm gonna turn my camera off.